Good morning. First of all, I want to thank ITAE Slovenia for inviting me here and for this really important moment to share some experiences about maintenance of tunnels and in tunneling. First of all, really few brief words about what we are going to see right now in this coming lot of minutes. We are talking about identification and management of the risk, and we are focusing on railway tunnels in my presentation. We also do road and highway tunnels, but we thought that this could be a right focus for the conference. We'll talk about the framework, a lot about technologies. As you heard, I am head of a technical part, but also innovation part, so I will talk a lot about technologies and about innovation. And also some practical aspect about sustainability in tunneling. And we will have a few slides also to talk about a case study. They asked me for a really old tunnel to talk to, and I will talk about a tunnel from the 1880, so it's quite old, and but really interesting case study. Really brief few words about who we are. This is not just for marketing purpose, it's also to understand a bit about the framework of what you are going to look to. The framework is that we are a civil engineering company that starts in the maintenance of railway infrastructures. So this is actually our core for now more than 30 years, more or less. And for this reason, we developed a lot of unique technologies for the railway market that then we expanded also in general for the infrastructures. And we are going to see some of them. Yeah, credits and partnership, that is just to remind that a lot of the things that you will see implemented here, they are done with the network of university, research institutes, with technological suppliers that are all around the globe. Let's talk a bit about the vision of what we are going to see. The vision is that the infrastructure is a social value, and this is undeniable, I think, because infrastructure links people, links community, links markets. So it's undeniable that the infrastructure has a social value and is a social value. Then in a framework of our really getting older and older assets system, it's really important, the strategic view for maintenance. And we are going to see why this is so important in a brief overview. First of all, maintenance, this is really provocative because we are, I think, all civil engineer here, more or less civil engineer, technical people working in infrastructure. They are like not mechanical engineer or people like this. Okay, fine. So this you find just provocative because people coming from the industrial sector, they always show this diagram that you saw on, you will see on the right. They will say that to have an efficient plant, you need at least to have a proactive maintenance, not at least a predictive maintenance. So it's obviously in our case we have a lot of aleatory in our sector, but it's just to say that our maintenance is mostly like reactive and planned. Just in few cases we are in the proactive predictive case. So actually it's some of our colleagues, they will say that our plants, so our infrastructures and our tunneling also, they are not so efficient from this point of view. In which framework we are going to talk about this? This is just an extract from a paper that collects data from, let's say, major authorities all around Europe. And here you will see some of them, and all of them considering also the Trans-European Transport Network. And here we show some data for railway tunnels. Then I will just add a few elements also for road and highways. As you can see here, we have a lot of tunnels in Europe, in Italy, in France, in UK. We are the one having most tunnels from the railway point of view. And the average age of this tunnel is, in some cases, more than 100 years. The data from Italy is a bit biased, because in the last 20 years we excavate a lot of mechanized tunnels. This is the reason why if you remove some of these tunnels, our average age will be the same as France, more or less. So we have a lot of old tunnels. They are like old people, and we are asking them, okay, don't get retired, please continue to work, and we need to find some strategy on this to let them continue to work. Considering then the materials from a structural point of view, you can see we have some similarities. The older countries, they have more or less the same material, different technological aspect, but for the material and the construction methodology, we have some point in common. And then as you can see, like the younger, we can call it the younger country, they also have some similarities. So most of the tunnels in Europe, they are still done with the masonry tunnels. Okay, now we will go inside the framework. The framework is that I will mostly refer to Archita when I will talk about technological aspect for tunneling, survey and inspection, and I will talk about MIRET for all the engineering and the analysis framework. But you will understand in a few moments what I'm talking about. So the framework is called MIRET. It's Management and Identification of the Risk for Existing Tunnels. So the principles are the same. As you can see here, you can recognize also some of the things that Farid was showing in the previous presentation. But here, what we are just saying is that for the maintenance and for the management of tunnels, what we need is an holistic approach. So it means that we cannot analyze the single component. We need to analyze the relationship between these components, because this relationship tends to have the whole system more important like the single elements inside. It's like more or less like a human body. We cannot analyze just the arm or the leg to say, oh, I have injury to my knee. I cannot just analyze the leg. I need to analyze the whole body to understand what is going on. And we will see what we can do from the innovation and state-of-the-art point of view for all these elements that you see here. First of all, the survey inspection phase. Nowadays, we have a lot of mobile mapping technologies that can help. In the destructive tests are really important, but we need in some way to collect data in a less intrusive way. This to increase safety, to minimize the impact on traffic, and so on. This is ours. That you will find also other elements, but I will just talk from what is unique from this system. So Archita is the mobile mapping system, multidimensional. We will see in a few moments what does it mean. Multidimensional is because in a single passage we can gather more than one information, so more than one dimension. And this dimension, then they are all taken together inside one environment, or multiple environments that are linked with them. So once we go to the passage, we gather a multidimensional system. In this case, we have different technology. Here you can see laser scanner, tunnel scanning system, ground penetration radar, and so on. But before talking about the system, just quick video that speak loud better than me. As you can see, this is like Archita going inside an old masonry tunnels, and then it's just passing with this light all around. We will see it, and you can see also our blue logo on the front. But that was Archita. And in that passage, what was Archita acquiring? Let's see. So first of all, we have the scanning system, which is like the equivalent of the inspection phase, like traditional inspection phase. So you have a photo scanning system that lets you acquire a prospect of the tunnel, as you can see on the bottom right. This prospect of tunnel has a precision and accuracy of 1 millimeter. So we can detect everything that is more than 1 millimeter. And linked to this element, we have the thermal camera. So the element that you see on the left is the thermal camera, and everything, they have profi meter, and everything is referenced. So the elements on the thermal images, you can just go inside the tunnel and see the correspondence between thermal images and HD photo. This redundancy is fundamental because, as you've seen also from the previous presentation, one of the major problems in tunnels is water. It's quite normal, and so it's fundamental to have this kind of redundancy to understand better some of the problems that you can encounter inside the tunnel. Then you have a laser scanner. This is to acquire 3D point cloud, and this is really technological aspect. We bought a fantastic new laser scanner, but you find a lot of fantastic laser scanner on the market. Then we have ground penetration radar on the bottom. Ground penetration on the bottom allows you to acquire information on the configuration, for instance, in rail about ballast, about voids, about humidity, about thicknesses, and in the road configuration, about information about the pavement package. So because this can work in both configurations, even if we are focusing on rail right now. Then we have something that is quite particular. We have a ground penetration radar for lining, which has a system like a semi-automated system to acquire on the lining during the mobile phase. And right now we are also investing on robotizing this element. So it's something that we are prototyping right now. Okay, then what is happening? This is just to help showing some of the things that I talked, that Arkita, as you can see inside the model, this is a tunnel that we are going to see in the case study later on. So the acquisition of the image, but with the image, with the point cloud, with the ground penetration radar and everything, what we are aiming is the element on top, is the vulnerability map of the tunnel. Exactly this is what we do. So we take all the elements in one environment, as you can see, the photo, the thermal image, the ground penetration radar. Then we collect them like a catalog, like also Farid was showing. And so this is just an example. In MyRet, all the catalogs are integrated for Italian market and some European standard. So we don't care if we are using one standard or another, they are all linked together. So it means that if we are detecting certain type of cracks, this automatically is linked to the catalog of the authorities that manage the tunnel. What is the result? The result is an informative model of the inspection. So what you see downstairs is the image, and on the top there is the digital twin of the inspection, just to use some fancy words that are really cool right now. But then what we can do next? So we do a lot of this inspection, we do a lot of vulnerability maps. So we are starting getting a lot of data since 2016, more or less. With all this data, we started a project 4 years ago to implement a deep learning approach and image processing approach combined for the automatic detection. So this is a really time-consuming element. So just to give you an order to understand, for one, you will need at least 1-2 people for a detailed map that work for a week for 1 kilometer. So at least. So it's really time-consuming activity, because this activity is fundamental for each European codes. It's the basis for the consideration then on the risk evaluation and on the maintenance evaluation, also with all the other parameters. So we need to assist, like another word that was used in the beginning, we need to assist in some way the people, mostly engineers and technicians doing this activity, and a deep learning approach is quite useful. So in MyRet, we have like a system package now that implements the AI support with mechanized concrete and masonry tunnels for detachment, cracks, and water defects. And as you can see, these are really fancy images that work really well. We also have images that works not so well, but it's also engineers, when they elaborate this data, they make mistakes, so we can excuse the AI. What is next step? Next step is take this vulnerability element, surface vulnerability and deep vulnerability. We can take this element and combine them with hazard and exposition. That can, in some approach, in a multi-level approach, they can be on the lower level. They are combined with simplified consideration. For the most detailed level, they are quantitative evaluated. In the end, what we have? We have a priority or risk matrix. That is the digital data that we manage inside the system, that we automatically process inside the system. So priority is when we have a qualitative risk analysis for the ones that to do this kind of things, and then the risk matrix is for when you perform a quantitative analysis inside. Then we have digitalization. So we got inside, it's a lot of these tunnels, sometimes we even have no information at all. So there are tunnels like for more than 150 years ago, there is no information at all. archives that don't exist. Sometimes they got burned during the Second World War in the 60s, the 70s. There are no data at all. So we go inside and with the 3D point cloud and ground penetration radar, we are able to get a model with the basic information level. So basic information level, we're talking about from the requirements that generally comes for the clients is sufficient for the preliminary phase, what we can get here. But obviously then we need investigation campaigns and other detailed process inside. Then we can integrate this solution obviously for designing. You know that we have a lot of solution on this. This is just showing one that we are collaborating in a lot. And now we can integrate this element directly in design element. This is possible right now. And this is also possible, coming back to, this is just a screen for the software that I was talking about, our software for the artificial intelligence and everything inside, also allows the planning phase. So analysis over time. So it means that you can get different timeline inside, and then you can get the information from this timeline and you compare them through time and so on. Here you can see an example for a mechanized timeline that we did in 2019 and 2020. The data from 2013, they are synthesized data. So we get like the manual inspection and we synthesize the image based on the manual inspection that we get. That was mostly on cracks in this case. And then this is an example like of the digital map of the inspection, some indexes that you can get. There was another, they were showing the difference here that everything is digitalized. So I would say it's a bit smooth together, all the things out. For the planning phase, I will also say a few words about sustainability and but practical aspect. I will not know. Will be not a rhetoric moment, but just an example to how important is this. For instance, if I get like one of these sustainable development goals, like the 16, I don't know. I think we all agree that peace, justice, and strong institutions are important. I don't know. If there is someone that disagree, can raise their hand. I don't know. Okay, all of us agree on this. Then we did the survey in the main fair and exhibition for we are talking about transportation market, and if you saw like the sustainability reporting, the commitment, and so on. For instance, the 16 sustainable development goals is never inside. So we all agree that peace is important, but then what we are doing in reality to make it real. And I live in Milano right now. I'm in front of the central station. I don't know if some of you know that the central station was used to deport Jewish people like secretly. There was a mechanical system, even sophisticated, for the area to bring them. So the Railway National Authority in Italy was like, let's say, blinded when everything was going. So it's not so, let's say, easy to say this and say, okay, but we all agree on this. Then we have to do something. And then from this really high speech, I will go really low and say what we are doing, for instance, for the infrastructure side from this point of view, and tunneling side. First of all, each innovation project that we have has a sustainability report. So Archita and Maret, for instance, they have a sustainability report. So the process is analyzed for the environmental point of view, social point of view, according to the European taxonomy and so on, for the ones that they know a bit about this. Regarding Maret Archita, we compare them with the baseline coming from the National Railway Authority and Highway Authority to say, okay, mobile mapping is good, artificial intelligence is good, engineering judgment, engineering algorithms, they are good if they are integrated with these, they can validate data, pre-assess data, and so on. But this, how much impact practically from the, for instance, environmental point of view? This is just an example, an extract from the report. So we can, for instance, cut the carbon footprint, this is the climate change mitigation part, up to 16 times compared to standard methods. I think this should be related in some way with something else. Regarding the other elements, whose water, circular economy, pollution, and so on, we are more or less like the same. We have less impact, but not so much. And regarding climate change adaptation, which based on risk, you know, I use the word risk a lot, but I think it's important. We developed another project which is called C2Risk, which is climate change analysis. So we take around the table universities, National Railway Authority in Italy, supplier, contractors, so we have experts from those people. We use this structured way to build vulnerability elements that was ported inside a social mathematical approach for this. And then we use the hazard part for the infrastructure done with meteoclimate downscaling and analysis of variables and so on. And in the end, this year, we ended up with the first railway in Italy analyzed with a complete vulnerability approach for climate change scenarios. And this is good because if you combine this with the other approach that you see, you can understand better in a single framework all the risks that you have. This is the final aim. And then this can go, this is just showing an example. Everything goes inside an asset management platform. This is just us, but it's just showing an example. The best thing is just to see the flow of the data of the contractor of the authority, understand the flow of the data of the contractor authority, and integrate things to ease the work at the most. This is, I think, the best suggestion I can get. Few slides about a case study to see also practically, everything was case study inside the first part, but to see practically in one really simple tunnel, let's call it simple. The opening of this railway line was in 1886, and the tunnel was built more or less in 1880. We are talking about an old masonry tunnel that had a lot of challenges when we jump inside the project in 2018, 2019. We have two closed tunnels. We will just see one. So there was no data, actually, no previous data about the geometries, about the state of the tunnel, and so on. So they asked us for inspection and mapping in the programmed interruption regime. They asked for objective data because then there was a lot of people have a lot to say about this tunnel. So it was really important to have an objective table to talk about it. In this case, in 2018, we were called about some hydraulic problems, but most of all, they asked us, okay, we need to execute this work then in compliance with railway operation. So interruption regime of 3 hours during the night for a month, and then we have just few days that we can close the line if we have to do other, let's say, more invasive strategy. So here, I don't know if you can make it start. And this is just to show the practical example of the digitalization process that we talk about Arkita along this line. Here, as you can see, we pass to the first tunnel, we pass to the second tunnel, we pass to the station, and this is not so fancy and automatic as you can see here, but is not even so it's so problematic as could seem. So but this really allows you to have let's say, a representation that can help the evaluation, especially in railway. It's really important that you have a lot of details about the rails and about the infrastructure part. So then, from the data from Arkita, we perform everything that you see before, the effects map that can be extracted and performed for each kind of analysis. Here you can see the example for deterioration and for water, for all the sector of the tunnels, an example of the map. Here, understanding of the problem. So we had also traditional investigation campaigns. We performed a lot of analysis. This was a design process. So in the end, to understand which was the main problem here. So, okay, we have water, but then the point in performing then a design approach that should aim in a quantitative risk approach is to understand the problem, like this. In this case, the problem, it's really simple if you saw the image. So we have the cut and cover tunnel. So we have inside the trench with, basically, we have clay, so we have mostly undrained soil on the bottom, and then we have really heterogeneous materials on the top that were used from different excavation during the process. So the aim is that basically all these elements that you can see, trapezoidal element is actually an hydraulic tunnel with an hydraulic trench. So the big problem of water was quite easy to understand if you looked at this image, and we have a lot of evidence inside. So after we perform all of this, we performed the hydraulic analysis, the structure analysis, and everything. At the end, we came up with this quantitative approach for the evaluation. So you can see all the different categories that were analyzed, like the geological element for the landslide, hydrology, hydraulics, the deep geological element, seismic, because it's, as you can see, this is really shallow tunnel, so seismic elements are quite important compared also to the area where we are. All the water detection in this case was fundamental water and masonry for the vulnerability maps. These were like the completely major elements. So we almost like focus all the attention on this part inside. And as you can see here, you have a representation of the risk that came up that then is related to other parameters. Here you can see for all the sector, and then globally you can see it for to the tunnel. Then we have from the information modeling, we can perform calculation, in this case transient hydraulic analysis. Everything was done in a formative approach here, and from the design point of view, it's quite useful. And then the process of the choices. So we have mostly consolidation and drainage system here in the different areas. You can see here, you can see an extract of profile and ground penetration radargrams from ground penetrating radar. And then we have works of maintenance. Here you can see some image from the construction, and just some of the image show. Here, the problem was an hydraulic problem, so we focus mostly on a drainage inside the masonry system. But then we finish the work, and what happens? It happens that then in 2022, the contractor for the rails and rolling stock, they were there for doing some work, and they found some ribs of invert, and something that we alarmed during our project. But then the data, they were not structured from one department to another. So then we had a really practical problem. I cannot forget this. I was on a marriage on August, on the 13th, and then they called me and say, no, we found some ribs. We will cover everything and finish this job. Now we need to perform new evaluation to understand which is the problem. As you can see, objective and challenges are always the same. They are not completely different problem, more from the structural point of view, different department, different elements, but the problem are exactly the same. So a new survey, this case with traditional element, because we all analyzed the really short stretch. So we performed the traditional laser scanner, traditional inspection, and a new defects map that was put inside the asset management system. As you can see, the intervention in 2019, they works fine, likely for us. And so the water defects, even was raining a lot in the day before, the water defects, they are really reduced. And but here the problem was facing the same process. So again, informative model approach. As you can see, we started from the as-built of the previous phase, and then we analyzed the new construction phases. Everything was again analyzed, and here the final intervention was to aim for where we found these ribs. At the end, we focused on the project of a new small invert in reinforced concrete that was linked with the masonry structure. For the other element, was sufficient to use a reinforcement system, starting from the injection to anchorage and so on. So I'm almost like finishing. This is just another video to show like the process that we saw before, but at the end you also find the as-built from the cases that I show you, especially the 2022. This is just to say that in this case, a really important lesson learned was that, okay, the system from the authority point of view was not completely integrated, but the people, they know that they have this data and they know about the process. So when they found the problem, they immediately say, okay, we have the system to look into this thing. We were able immediately to get the data and really like, I would say really fast compared to the time of design and construction that can take years sometimes, especially from planning this. And the first element were done like in days here, because we already have a framework to put on with all the investigation campaigns, the models, and everything that we did. And then, this is it's always nice to be shown. In this case, for the invert works, everything was fine. For the 200 meters tunnels, the job was done in less than 10 days, more or less, everything that you see here, with a lot of let's say technological adjustment during the construction phase, and we are, let's say, quite satisfied with the results. So thank you for your attention. Here you can find also my email, my contact, because now we have questions. I will be here for these days, but for everything you can just write me and we can talk. You can add my LinkedIn or whatever. I'm an available guy. Thank you.
Thank you, Federico. I can say I'm impressed, and again, I'm not from this field. My background is IT, computer science, and what you guys are doing is pretty impressive, especially the AI part and so on. And we do have two questions, at least two in Slido, and then also from the audience. Matisse, if you can just put it on, because both of them are actually tied to the system that you showed. And one of the questions that you might, we still don't have it up, that you might expect is, I can read it when we wait for this to come on, is how much does it cost? You said like it's way faster than having people, and again, having people also costs for, let's say, a 1 kilometer long tunnel. And then the other one is, then once you have this, the analyze, you said the question. Yeah.
Cost and time. I say, I'm not surprised. I'm not surprised about the question.
You get this, yeah?
Yeah, a lot. Regarding the system, I would say that from the engineering point of view, the correct answer to say, but then I will detail. It really depends on the context that we have. But I will give some introspect on this question. Is because first of all, we are engineering technical people. It will be, for me, from my point of view, at least from what I believe in, will be really stupid to me to say, oh, it costs like 1,000 euro for kilometer. It will last 2 weeks for 1 kilometer of data to analyze everything. It will be really stupid after everything that I proposed here. But the point is that this is a design process. So when I perform a survey like this survey is designed in a certain way. Is inserted in a plan which is designed the same way around. So the point is that we need to understand logistics. We need to understand how many kilometers that we are doing the same stretch, which interaction regime we can have at our disposal, because maybe we have 2 days, two nights, and we can perform like 20 kilometers of tunnel, because this is the number, like 2 nights we do 20 kilometers of tunnel. But then we have like 2 weeks of interruption, then we can go back. So logistic is like twice, and this is really common. So for the people that works on the maintenance field and inspection field, this happens all the night. You have always like some problems, then you have to go back to next night. Maybe you have to go back after 6 nights, and everything is really like on spot when you perform. So it's you can give like some element. For instance, for the first question, after this introduction, if I have a 1 kilometer long tunnel and I have to analyze like all this data, again, in which stage of design I'm in? If I'm in a preliminary design stage, I'm in detailed design stage, I'm in the same design for construction, which is the stage? So if I'm in preliminary design stage, I can take most of the data that I look into and I can use them almost like directly, like with the processing of a few days. If I'm doing a detailed design phase, that can be done with the data that are coming here, integrated with others, then maybe, depending on the problem that I have, this can be last 1 week, but can last 3 weeks, can last 1 month. If I have problem that I have to detach all the single cracks in a 3D environment, not just with the panel, I can also have like 2 weeks, 3 weeks on it. Depends always for what we are looking for. What is the problem? And I think this is the best for our case, because we cannot, we have standardized some elements, so we have standardized the technology, we have standardized also time, prices, and other stuff, but we have range that needs to be adapted to the specific problem. And this is the most important thing, because we are all like technical people and engineering here, because so it means that there is also, even with this automation, there is a lot of job for us to be done. And regarding cost, is even like the same elements, but it's doubled, because then depends on authority pricing, depends on system for pricing, depends on tender phase, depends on offer phase, depends on so many things that you have there. But regarding what I can say regarding architect, if you go like to the national railway network system pricing, which is some elements are open, you can also find like our system inside price it. So it's, let's say it's some of these elements are not secret. You can just go and look into them, and but then needs to be specified for the problem.
All right, thank you. I'll consider the questions answered, so they will disappear now. Oh, yeah, and we have another one for Farid. All right, so Farid is going to get the mic to answer this one. What did you mean under better use of BIM and GIS in AI? And then we'll get back to your questions.
So,
if there's a light. You got it? Okay.
so in terms of BIM and GIS, I mean, I guess it's for understanding how new construction will live and have an impact on our existing infrastructure. Now, in terms for BIM, what you can do is working when you're doing your new designs. If you can map all your existing infrastructure, you can then plan and you know where everything is subterranean. And even with other services like other gas, water mains, etc., if you've got a BIM plan, 3D plan, which you can identify where everything is, so then when you're building your new infrastructure, you can see how close you can get, how far you need to get, whether you've got any clashes. So I think that's what I meant by BIM. And in terms of GIS is a system whereby you can use a map we've got a map of our network, we've got GIS, where you can then click on a particular station and it will bring up all of the necessary information you have on the condition, the type of tunnel we've got, the length of the tunnel, the type of lining we have, etc., which can help projects but also help our maintenance. So rather than having everything on a database, you've got a map where it becomes so much easier for you to go and find the information you have. So behind that could be the database, but the front end could be the map where you can just go and click on it and you can find all of that information. Now, in terms of artificial intelligence, I really meant what I meant there is machine learning. So when we're doing inspection of our tunnels with these automated inspections, you showed a brick tunnel. So the system needs to understand, you need to find historical photos showing particular types of defects. So you've got to teach the system that when it does the scan, this is a defect, yes, this is a crack. Or if it's going through from brick tunnels to a concrete tunnel to a cast iron tunnel, it needs to identify, I'm in a different tunnel now, and there are different set of defects that the system needs to look for. So that's what I mean by artificial intelligence, more about machine learning.
All right, Federico, if you want to add on to this.
Yes, definitely. I would just want to add from a really technical point of view that it's correct, and we have also another problem in civil engineering generally, that the models, most of the models that we have now for artificial intelligence for the recognition of tunnel linings, they are not so good. They need not only training, they also need some calibration, but only in training, also in parameters and other things. They need some work from the implementation point of view. And this is something that we realized because when we started the first year, we took like all the models and everything, all these papers, fantastic papers saying, oh, we will have a precision of 99.5%, 95%, 90%. Everything was fantastic on paper. Then we were taking like the crack, with perfect lighting on the blank surface and so on. And we realized that the reality of our tunnels, like the image that you showed for it, so image that here, the reality of tunnels is really different. The lighting system is really different, the condition is really different, the working condition, then they are really different. And then you cannot go for what in the first years was published a lot, it was advertised a lot. You need to have some compromise, and this compromise needs also to be modeled from the mathematical point of view, from the training point of view. And this is regarding all the main civil engineering point, but tunneling especially, because they are really tricky for the lighting, for the access point of view.
All right, thank you. Any other questions? We do have a lot of time, so we can take a couple of them.
Hiya.
It's fine. We can hear you.
Okay, so just a quick question. If you're using an AI-based approach, how do you determine a level of accuracy that is acceptable? Because maybe you achieve 95%, but what is that 5% that you're not seeing? Is that could be a really important part of the tunnel structure, for example?
Yeah, actually, this is this question is really important because really talks about a lot about the misinformation that we were talking about before. 95% is what is on paper, but on paper published paper is not our 95%. Let's start from a claim that looking for the people that start before us, civil engineering. For instance, in Medicare, for diagnostic reason, they have an acceptable level of, for instance, accuracy and recall, precision and recall. Just talk about main values, which is acceptable between 70 and 75%. So all the meanwhile that there was this, so the Medicare sector was going forward on this. We start publish a lot of things on cracks and water, saying that precision accuracy must be 95%, 90%, showing the perfect image, the calibration, and so on. This took a lot of misalignment between us and another sector. Because if we are talking about diagnostic element that they can have a similar problem, because Medicare, they have similar problem, especially when you talk about magnetic resonance and all this kind of things. They have similar problem to the detection phase that we have here. Here we have some problem even more, because we don't have the condition that we can take a person inside the machine. We can gather the data like we are completely fine in gathering the data and so on. So I will say that starting from that, all the calibration work that we did in these last 7 years, more or less, allow us to say that a good value. Here, I'm happy to give a number because it's important information. This is maybe 60%. If for the Medicare is 70%, for us is 60%. In the comparison phase, can even be 50%, 55%. But then, what we are missing? The question is that it's not just what we are missing, and what the AI is detecting more compared to a human. Because for the calibration phase, we are using defects map, where like we have on 1 kilometer of tunnels, we have in one tunnel we had like 700 meters of cracks, and everything were completely like detect on them, and they were used for the training and so on. But the reality is not this one. The reality is then you have main cracks, you have a network system of cracks, you have other elements, and you gather this element. Sometimes single, sometimes aggregated, sometimes in other way. So the point of this AI is that if we are missing 30% of the data compared to an equivalent human detection, it also means that we are gathering more data compared to human detection. So for one case that we did this kind of analysis, we realized that we had a loss of data more or less about 10%, about 15%, but we have a gain of data that was another 15%. So the answer is that for me is not completely, when you have a certain maturity of the model, it's not correct to compare them totally from the human acquisition. AI is a thing, human acquisition is another. Human is a bottom-up approach in the analysis, AI is top-down approach in analysis. So here we are trying to reverting the paradigm on performing this inspection and maintenance phase to try to moving on aided system. It's like when it was introduced, like CAD was introduced. It's the same things here. So I don't know if it's a satisfying answer. Okay, perfect.
All right, thank you. Another question in the back.
Thank you, Federico, for the great presentation. So you do the inspection with the Argita, and then you do the risk analysis or something. How do you include the factors, or let's say, how do you include the factors in this risk analysis? So the things that you cannot scan with the Argita, for example, drainages or stuff like that.
Yeah. So really interesting question. I have a few minutes.
Yeah,
right?
you do. We have
okay,
enough time.
okay,
Yeah. Just go
okay,
on.
perfect.
Go on.
Also here, it's really important to understand.
If you want, we can switch to slides. will it help?
Yeah, that it would be the same, but yeah,
Okay.
it's okay. Okay. Don't worry. I can talk during a minute. And so it's really important to understand the stage in which we are with the analysis. If we are on a preliminary stage with a less technological tunnels, when we are talking with less like few utilities and elements that can be seen but cannot also be seen, like the one that you were saying, then it's acceptable to proceed with all the evaluation with the data that we have right now. An example, we are analyzing like now with all the approach, also with the artificial intelligence parts, with Archita, with everything, we are analyzing like 20 kilometers of tunnels in 1 month with three engineers right now. And we had a lot of tunnels in which don't have the information like drainage system and other elements. So, but the point is that in this stage, is the authority interested in this information? All this information are compelling for the risk evaluation in this stage, or can be really practically like and not available in this case, or like a sort of prescription to go in further details before. This is always part of the design process at the end. So always risk evaluation is a design process. The evaluation is a design process, the risk. So the answer is that with the Archita, in certain type of tunnels, you can go even to the detailed phase, like with this type of tunnel, for instance. The main utilities, you have the drainage, you have the evidence right now because you have the shotcrete on type, so you know there was drainage, you can see the pipe there, because that system was done with the sewage system to be inspectable and to be seeable. Then you have the traction, and you have other elements, everything is seeable. So with that data, in that case, you can go until the design phase. You can go here in even like construction phase in the first part. Obviously, if we're talking about a technological tunnel, like for instance, now we have another railway tunnel that has a really complex system for the hydraulic dispersion, because it's inside the mountain, and there is a big reservoir inside this mountain, and so this reservoir is connected to the tunnel with some kind of hydraulic system, which they also have like a room with pumpage system, a collection, something that goes inside the drinkable infrastructure, really complex. So you cannot analyze like hydraulic category without taking account this data. But in this case, you know that the data are compelling because you have some evidence, or from the authority or from the inspection phase. You will always have some evidence on this. And then you go directly to the data that you need. You say, okay, now I have 3 days. These 3 days, I will invest the pumping room. I know that I go inside the pumping room, and I need to see with the ground penetration radar the connection between the tunnel and the pumping room in a certain way, and I will focus my assessment on that part. So in this case, what can be done with Archita Minute, what is the point, is that if I collect everything in a data environment, everything is digital, I can look into these things like more, let's say, more quickly. And what I can do is I can allocate resources on when I have most problem. And I can say to the people, okay, your problem is mostly here. So tell me what you need to do more, what you need to further elaborate on this, and which data you need, and to put like the right factor inside the analysis. And regarding the analysis, in the end, there is a lot of calibration and quantitative risk analysis, for instance. There is a lot of calibration that not only depends on our consideration, but also depends on the characteristic of the infrastructure. For instance, in the railway, we have a database, and the one that we were showing like before here. Okay, this is like a multi-criteria approach that you can see here. For a multi-criteria approach, you need some weights that you need to put inside. And these weights are calibrated by the consideration that you made, but also calibrated based on the experience that you have on the line. So putting together the experience of the authority, putting together the analysis that the design made, everything was put together to calibrate also this factor, because then you have a lot of territorial elements that are really important, not only like technological, also territorial elements. You have urban elements that can interact. You have the user accountability in some way. So all these things needs to be then put inside the approach. I don't know if it was okay. All
right, we still have a couple of minutes. Some more questions? Yep, Farid's got one.
Hi. Just a quick one. How fast does the vehicle travel? And in terms of what's the per kilometer or whatever it is, how long does it take to scan the tunnel? Because obviously that's probably dependent on your equipment.
Depends on the configuration, but it works at 20 kilometers, between 15 and 30 kilometers per hour. This is why I was saying that in 2 nights we more or less with standard interruption do 20 kilometers. And depends on the configuration. Obviously, for the ground penetrating radar, you need more passage for the longitudinal side. And then for the diagnostic element, you just pass one time and you are okay. Also for the topographic configuration, you have one passage and you are okay. Then depends on the regulation, so legal compliance. For instance, in Italy, if you are going to do an inspection, the inspection is a construction site. So you are limited to 30 kilometers per hour as speed. So our working speed, everything is calibrated here to work perfectly at that speed. But some instruments, because it happens sometimes also for us, some instruments can work all at high speed. Like ground penetrating radar can work 100, more than 100 kilometers per hour. This photo scanning system, you lose something obviously on precision and accuracy, but you can go more than 70, 80 kilometers per hour. But from my understanding, it is really more like a legal compliances in most cases, because you need to deal also with the safety issue that are really important.
Okay. And the vehicle that you showed, that's bespoke for that. So we in our underground, can you put a system together that will fit and be appropriate for us? So we would have a wagon, for example, a flatbed, and it needs to be on that.
Yes, we already did something because we did all the Rome subway system. So it's 45 kilometers, more or less. So we already used the system for the Roma subway. So we did like a sort of customization to fit on the, let's say, on tracking, spacing, and other considerations that were around. And also we had like a project for to use the system with TBM also. So in this case, to take some of the elements to work like behind TBM and so on. So it's like modular and can be customized, needs to be analyzed on the specific case, but we did it.
Okay, just one more question, and that's related to your data. Now, is your data in a common data format? So, for example, we engage with you as a supplier for a 5 or 6 years or whatever it is. However, the data we want to keep, I understand the black box and the algorithm is yours, but is the format of the data common so it can be picked up by other suppliers?
Yeah, in our let's say a sort of informative execution plan that we have with the system, everything is also in exchangeable format. So the point cloud is in A57, the digital model are in IFC, the radiograms are in JPEG, the tunnel scanning system is in JSON and can be exported to CSV and the XF. So we are according to the compliances to the standard, uni-standard for informative models inside.
All right. 2 minutes, one quick question maybe, if there is one. Yep, there's one.
Thank you. Just a quick question, if you can have a few information more about the risks you mentioned. You were talking about risks really a lot. What means the risk in your context? Thank you.
Thank you. No, it's not a 2 minutes question on this, but we'll
sorry.
No,
yeah,
no. Then we can
later.
continue. We can continue at lunch.
Yeah.
It's really interesting topic. I like the question. So what we mean by risk, without going inside the, let's say, the like academic things, but here what we mean by risk, we mean to have an objective evaluation that can help us prioritize element on to assess then a particular loss or gain that we can have with a certain events happening. So with these things in mind, risk is a multi-level approach. Multi-level, not only for the detail, but also for what we assess. In Italian regulation, we have, for instance, highway roads tunnels, we have two. For the qualitative risk, we have two levels of risk, which is global risk and hydraulic risk. In global risk, we have global structure and geotechnics, local structure, geology, seismic, and road, the infrastructure part. So I would say that these elements are basic to start an evaluation to define the first level of risk. After this, when you pass to the quantitative risk approach, then depends also to what we had in the previous phase. For instance, we have a tunnel with tunnel like this one, like in 2018, the problem was mostly hydraulic. So our risk analysis was at the hydraulic stage. So we perform all the hydrologic analysis, hydraulic analysis, seepage transient analysis, and so on. And with this, you determine the probability of occurrence of element with the consequences that you can have, because we measured the water defects. In this case, you can have, starting from the evidence, you can have a probabilistic and then risk approach to this, because you can say, okay, if you are accepting this time for this to happen and this, then what you will have this water entering inside the tunnel with a certain level of probability and so on. If you have a structural risk like the second phase with the ribs was different, because if I remove these ribs, which is my risk right now from the structural point of view regarding the invert especially, which would be the risk if I remove this. But this is all calculation that we do. We do all the calculation with FEM, another software and so on. But the point is then to put this analysis in a framework when you can calculate a probability of occurrence and the consequences inside. So obviously you need also data from the authority, because to calculate the consequences, you also need to have precise data on the exposition. For instance, in the case the number of trains that pass during the day. You need some law. In the railway sector, there is standardization, for instance, to calculate the impact of elements on train and the life loss for the train. So you can calculate risk in terms of life loss. And so there is a lot behind from the logical point of view, from the standardization point of view. And then the last one which is important is legal compliance always. Like for instance, in Italy, there is the risk is not allowed from the safety view. There is not like residual risk. The risk must be zero. We still have a law which is like this. It's different, for instance, to, I don't know, for Switzerland, consider one which is really close to us, or other countries. So if you do an intervention, there is not the concept of residual risk inside. So they invented like a different terms. They call it attention for this. But the concept is the same. So you have also the level then going up, then legal compliance, which is up to the standardization.
Thank you.
Yeah, you are welcome. We can further elaborate on this. It's quite long, I know.
And as we said, we're going to continue. I mean, you can continue one-on-one over lunch, because as a rule, you can't really put anything between a human and his lunch, which is now. So thank you again, Federico. Thank you.